Hey ladies and gents, today we're going to take a look at how to do a test of independence using a test of independence template, one that I built for you and should make your life a lot easier when you're doing the big project. Now in Unit I, when we looked at the test of independence, we did it basically by hand. We created a pivot table, and we'll still need to use the pivot table here to create the table, but then we did everything else by hand, and this will actually cut down the ladder steps here and just make it a really easy thing for you to do. So let's take a look at a couple of problems. I'm going to start here with a problem right from your manual. It's from page I7, number 2, and the question was, looking at the relationship of the size of the business and the importance that they place on advertising. And the HO, of course, is that the two are independent versus HA, which is that they are dependent. So I've got a bunch of values here. I think there's about 360 or something like that. And so each is a respondent. And what we've got is the business size, and it's either in medium, large, or medium, small, or large. And then we've got here advertising is either important, not important, or no opinion. So one thing I want you to note here is that as we go down here, you find that occasionally you end up, such as on number 43 here, is that we don't have some data for this. And I'm going to go down a little bit further here. Here's another example where actually this particular respondent didn't answer either of them. Why? Well, this could be two columns out of a bigger survey. And so they did answer questions out of from the other questions in the survey, but they didn't answer these two. And so we can't really do the test of independence for that particular individual, nor for this particular individual right here. So we do have these occasional blanks here. Here's another blank right there. That's not a problem when you're dealing with pivot table from Excel. It'll actually allow you to filter out the blanks. So let's set this thing up here. I've got the three columns here: the respondent number, the business size, and the importance that they place on advertising. And it's in a little block here of three columns. So we've got titles across the top here, and then these are contiguous columns, right? They're all together, and contiguous rows, they're all together. And that's why I always like to keep a respondent number, because everybody has a respondent number. There's no blanks there. And of course it's completely set aside from anything else on the page. So you've got a completely blank row underneath this little table here. We've got a completely blank column right beside it, and then I've got stuff at the top here, but it's completely blank above it. And of course there's nothing to the left in this particular case. So what I do is I click anywhere in the list, right? Excel calls this a list of our data set, and it is got all of our variables there. So I click there, and now I'm going to go to Insert at the top here and choose Pivot Table. And what it should do then is, if I've set this up correctly, then you should see a selection box around all of the data here, including the titles. Now, by default, this goes to a new worksheet. I'm actually going to put it on the same worksheet here. Let me just find a spot here up near the top, and we'll put it right there, and press OK. Now that gives me just a blank pivot table here. So what I do is I go here, and you'll notice on the side where it's got the pivot table fields, I've got respondent number. So I'm going to click on respondent number, and that goes to the bottom right where it says the sum of the values. Now the default, because this is a numeric variable, is that it sums up the numbers from 1 up to 360 or whatever it is. So that's why you end up with such a big number here. I'm going to just right click there, right where it says the sum of the respondents, choose field settings, and change that to account. And now that should give me 360. All right, the next thing that I do is I'm going to grab the business size and I'll pull that down. It doesn't really matter whether it's rows or columns here. So I'm going to put it down here for rows. And then I'm going to grab the advertising and move them over here to the columns. Now, one thing to note here is that I can change the order of these. So for instance, I think in the book I had small, medium, and large. So what you can do is you can click on where it says small and just drag that up. So notice that I've highlighted the cell small right there. And then I move my cursor up to the very top until it turns into a hand. And then I click and I drag it up like that. And I can do the same then. I can either move medium up or I can move large down. But now I've got small, medium, and large. And then I've got important. I think I had not important next. So I click on not important and grab it by the hand and just move it over here. So I've got important, not important, no opinion. Now the other thing you'll note here is that I've got these blanks. So I can filter those out. If you take a look at where it says the row labels here, you've got a little down arrow here, and I can deselect any of these items here. So I'm going to deselect the blanks, and that gets rid of them. And then I can do the same here for the column labels, because I've got some blanks here. So I'm going to deselect those, and I'm left with what we've got then in our manual here. So it looks like that. All right, now I want to introduce you to the Test of Independence template, and I've already opened it up. It's right here, and you'll find that in your supplementary files folder. And I think you'll find this to be a really useful little thing here. So I'm going to go back here to the pivot table, and I'm going to click on where it says row labels. And I will highlight across and down, but I'm going to exclude the totals. So it's just really the inside cells and then the labels, the column labels and the row labels here. So just those guys right there, ignore the grand totals. And I'm going to copy that. So I'll just do a Control C here. Or I can go up here to copy, of course, and I'm going to move over. And then I'm going to go to this gray cell up here where it says the observed frequencies. What I'm going to do is I'm going to not just do a straight paste. It will actually work with a straight paste, but it just looks messier here. So what I'm going to do is a paste special. If you go up to paste, there's a little drop down arrow, and I'm going to choose the paste values like that. So it looks like that. So I keep the nice formatting here. Alternatively, I could just simply click in that cell and right click paste specials, and you will find the values there as well. So that gives me what I need. Let me just make this a little bit bigger here, and let's take a look at what we've got here. So it gives me my EIJs right here. And notice actually that all of the EIJs are a healthy size. Remember that we can't have any of the EIJs less than 1, and no more than 20% of the cells can have EIJs less than 5. I've actually got a message that will appear, and we'll see this in the next example. There'll be a warning message if the EIJs are too small, so we'll see that next. But I go over here to the results here, and what it shows me then is my chi-square star value of 29.64, my alpha here, and by the way, that alpha you can change. I mean, I could change that to a 10% like that, and I think in fact that is what we have in that particular example. I'm just going to go here and do a real quick check here. And it says, yeah, a 10% level of significance. And so that's what we've got here. So we can change the alpha right there. And the critical value turned out to be 7.78. And the p-value is 0. This 29.64 is way out in the right tail. It's much larger than the 7.78. And so this indicates then a likely strong dependency. Anything under 1% would be a likely strong dependency. And then between 1 and 5%, it would be a significant relationship, so a likely dependency. And then between 5 and 10%, a possible dependency. And then above that, it's unlikely that there is a relationship or a dependency. So that's what we've got. Now, there's one other thing I want to show you down here, and that is that in class, the question was always, well, how do we analyze this further? Once you reject HO and come up with a statement here that there's a likely strong dependency, then that's saying that some of these Fij's, the observed frequencies, the Fij's, are significantly higher than their corresponding Eij's. But which ones? And what we did is that most of the problems that we were dealing with were in the kind of 50 to 100, 200. This one's actually up to 360 or 356 once you get rid of the blanks here and so on. So we're typically looking at, well, if the Fij is 3 or 4 or 5 more than the Eij, then you want to highlight that. But it really depends on the numbers, right? If you had, say, 10,000 values in your table here, so a really large N, then a difference of 3 or 4 is almost nothing. So is there a better way? And so what I've done here is I've added this thing, which you're not going to have to do by hand, but it actually shows you the differences here between each pairing and whether they're significantly important or not here. So it's looking at each Fij and its corresponding Eij, and it actually comes up with an adjusted standardized residual. Now, you don't have to know what that's about here, except that it's actually based on z-scores. And so down over here on the right, I've got a table here that tells you how to read this. And so remember, if we were taking a look at a typical Z-test, we would have, for a 95% level of confidence, that you would have plus or minus 1.96 would be the critical value. So it's actually using those kind of numbers there, and that's where this 1.96 comes here. So we look up here and we say, this particular value here is really, really small. It's got a really low standardized residual. So down over here, we say anything where the standardized residual is less than minus 2.58 indicates a much lower than expected count. So this particular guy up here, this 20 is much lower than this 40 here. Right there, okay? And then we can come across here for small, and this 3.32 is really high, actually. So that's got a very high adjusted standardized residual here. It's greater than plus 2.58. So that means that this is really high. And of course, if we take a look at the numbers up here for the small, we see that this 52 is actually quite a bit bigger than this one here. So what that's saying here is that for smaller firms, smaller businesses here, then the importance that they place on advertisement is far less important when they're small than we would expect, and there's a much greater number that say it's not important than we would expect. As far as no opinion, that's also in the kind of the strong area, but that's because we're actually looking at all of these together here. Let's take a look at large. In large, it's exactly the opposite here. So we've got a very large standardized residual here, and that would indicate then that the larger industries place much more importance on advertising, and the smaller industries, or businesses, pardon me, the larger businesses place much, there's far fewer of them that place no importance on advertising than we would expect. So it's the exact opposite here. What's interesting is that in the medium-sized businesses, there's really no significant differences here. So when we go up here, I think when we did this in class, what we found was that for the small, we said that that these two were larger than we expected, and these two were larger than we expected here. But really, this is giving us a better picture here in terms of where the differences is. This is significantly smaller than we expect. This is significantly larger than we expect. This is significantly larger than we expect. This is significantly smaller than we expect. And that's how you actually describe the relationship here. Okay? So that's the first example I want to show you here. Let's take a look at one more example here. And what I'll do is I'm just going to get rid of these guys here. So we've got a fresh template again, and I'm going to go back to the other problem down here, which would be the town versus highway. Now, let's take a look at this question here. This is not one from the book. 340 residents were randomly selected from 5 Alberta communities, whether it's a city, a town, or a hamlet, and they were asked the question, have you ever experienced significant or frustrating delays in the past year due to highway construction close to your community? One thing I want to note on this particular thing here is that this probably is not a great setup for a particular problem, and the reason is that you will see when we take a look at the data here is that there's the 2 big cities, Edmonton and Calgary, and then there's 3 little hamlets. And it's true that they're all along Highway 13, about halfway between Red Deer and Edmonton there. But is that really a good representation then of the hamlets? And you might look at that and say, well, yeah, but if I had a lot more, then I wouldn't be able to do a test of independence because I'd end up with this massive table. And what I would say in that case then is that, well, maybe it's this question that you have to change here as more of a rating scale. So this is just simply a yes, no, or no opinion. Have you experienced significant or frustrating delays in the past year? Yes, no, or no opinion. You can see those 3 different options as we go down here. And that might be better as maybe a 5-point Likert scale, where you say how much delay has there been, and it could be very insignificant to significant, or very, very little to very much would probably be better. So very, very little, neutral, and then much and very much, that sort of thing. And then you've got nominal versus ordinal, and you could use a Kruskal-Wallis test for that. And you can actually have a larger number of columns for that particular one, so a larger number of different towns. You could also take a look at different regions in the province then, and select a few towns from each one and put them together, and yet still have maybe some of the bigger cities, Edmonton and Calgary obviously, but maybe even Red Deer and Lethbridge and so on, as separate entities in themselves, but then have collections of counties, so you get a good feeling for all of Alberta. So the setup of this particular question isn't terrific. That's the important thing, is you want to take a look at your sample design to begin with, and your questionnaire design. But let's continue with this one here. And really what I want to show you here is what happens when you end up with low counts. So I've got the respondent number. There's about 360 of these. 340 or 50 or something like that. 340, I think. The community, and there'll be 5 communities here, and then the answer to the question, which is yes, no, or no opinion. So I'm going to click anywhere in here, and I'm going to go to Insert a Pivot Table, and I'm going to press, let's put this in the existing worksheet again. Keep this on the same one. So we'll put it right in here somewhere. And there's my empty pivot table. I'm going to choose my respondent. Click on that. Right click down here at the bottom where it says Sum of Respondents, and I'm going to choose the field settings and change that to account. So I've got 340. And then I'll take my community and I'll put that, oops, click and drag that down here to the rows, and click on the highways and drag that down. By the way, if you just click on the highways, what it does is it actually puts it down in the sum of the values, and that's not a problem. You can just simply click and drag that up now, and it will change it back into the counts here. So this is what I end up with then is I've got Calgary, Edmonton, Gwyn, Westeros, and Winfield, which are just small little towns or hamlets here. I've got some blanks. Let's get rid of those. So I'm going to click on this down arrow here and deselect the blanks. That's good. And then over here I've got some blanks, and so I'm going to click there and deselect them. And I could reorder these if I want to. I think they're fine the way they are. Calgary, Edmonton, and then a bunch of little small towns here. And then we've got no opinion, and yes. And that I could change this around if I wanted, so that it's, you know, yes, no, and no opinion. I could do that, and that's just simply moving it over like that, but it doesn't really matter. Now, what I do is I click on where it says row labels and highlight just the inner cells and the titles. So again, I don't include the grand totals for the rows or the columns. And I'm going to do a copy. I'll just simply do a Control-C on this one. I'm going to move across here. I'll right-click in here where it says Observe Frequencies, paste specials, paste special values. And this is what I end up with. Okay, let's take a look at this. We've got pretty healthy numbers when it comes to Edmonton and Calgary, which is what we would expect here, but Gwyn, Westeros, and Winfield have really small totals of 5, 7, and 7. And here's where you end up with problems here, is if you take a look at the EIJs, we can't have any which are less than 1, and we shouldn't have more than 20% of our cells less than 5. We've got problems here. And so you'll see that there's actually a warning here. Warning, you have too many expected counts less than 5. So combine cells. So how do you do that? Well, there isn't any point here in terms of combining the columns. For one thing, the column totals are quite healthy. That's not where the small numbers are. So there isn't any advantage to combining the totals, besides the fact that you can't really do that anyways. Like, you can't put no opinion with no. Does it go with no? Does it go with yes, or what, right? So it wouldn't make sense. So if you ended up with a very small number here for no opinion, maybe the total was only, say, 5 or something like that, you couldn't really put no opinion with yes or no, so you'd actually just get rid of it. And when you do the write-up, you would note that. Now you'll run into the same thing when you're doing gender. So if you have a question that says, what is your gender? And you've got male, female, and other, and then some of you have no opinion down there, what you find is that most people will put down either male or female. That's not to say that the other choices aren't important. It's just that in a test of independence, they won't be large enough numbers, likely, that we would be able to actually use them in the analysis. The EIJs will be too small if we're only talking about, say, a total sample size of 100 to 200. So what you do then in your write-up is you actually write in the write-up, you note those, that 5 people chose other and 4 people chose no opinion, but we couldn't use them in the test because of the small frequencies. So then you take a look down here and say, here's where the problems lie, is we only have 5 for Gwyn, 7 for Westerose, and 7 for Winfield here. And you can see those down here in the very small EIJs. So you'll need to either get rid of them or put them together. Now, we could make an argument here that we could put them together. For one thing, actually, all 3 of these are on Highway 13. And so Highway 13 runs right through them, and the question is about highway maintenance, or about the condition of the highways and the delays caused by construction. And so we could say, yeah, that makes sense. If I had, say, 2 on the same highway and then I had 1 way up north, then you have to ask the question, does it make sense to put them together? Maybe I'm looking at the big cities versus the smaller communities, and that may make sense. But you really have to take a look at what is it that you're trying to get out here. And so you want to talk to your decision maker about, does it make sense to put these together and analyze them together? Let's assume that we have talked to our decision maker or our client, and they say, yeah, well, Highway 13 runs through all 3 of those, and so let's put them together. So what I would do is, instead of going back to the original pivot table, I would just do this manually. And how I do this is I put these together. I'm just going to call it GWW, and then you can go and change that name actually later when you're actually doing your write-up. And then I'm just going to manually add these together. So 3 and 3 and 4 makes 10, and then 1 and 2 and 2 makes 5. And then 1 and 2 and 1 makes 4. And then I'm just going to get rid of these guys here, like that. Now, actually, the way that this thing is set up is that this actually gives me the correct answer. But I would probably, just to make this nice and clean, is I would copy and paste this here and then get rid of this row right there. So now we take a look, and remember that having a low Fij is not a problem. You can even have zeros for Fijs. It's the number of Eijs that we've got. And we look here and we say, these are good, these are good, these are good. We've got 1 here which is less than 5, but we're not getting our warning message because we've got less than 20% of the Eijs less than 5. So we're actually good here. So we go here and we take a look at the relationship, and it says here that there is a likely strong dependency because we end up with a high chi-square star value. My alpha, I'm just going to change that back to 5% here. That's usually what we have. And but your p-value is still 0.3%. That doesn't change. When we take a look down here at the standardized residuals, then what we'll see here is it's in the big cities where we tend to get the strong stuff here. So what we've got is that in Calgary, we end up with a lower than expected yes. So we're saying that in Calgary, they're not saying that there's a problem, much of a delay in terms of highways. Now, by the way, this is just made up data and so on, so I don't know whether this is true or not. And they're saying that there is a much higher than expected number of no's. So again, up here, what we're saying is that for Calgary, this 52 is much lower than this 69, and this is much higher. The 78 is much higher than the 64, significantly higher when you take a look at these guys right here. Okay, and the chart that we use is down here when we're taking a look at them. So we're looking at this one, a much lower than expected count and a much higher than expected count. And then with Edmonton, we end up with the reverse here. So Edmonton seems to have more trouble with the highway delays, according to its residents. And so more yeses than we would expect and fewer no's than we would expect. Down here, what we find is that actually there isn't any significant differences here. So there isn't a big difference in terms of the yes and the no's and the no opinions here. When you're writing this up, you can include the whole table here, or you can look at this and say, well, we're just going to look at Edmonton and Calgary here and get rid of the last one. Okay, so we finished up the analysis using the Test of Independence template. And now what I've done is I've just transferred over the results here into a Word document. So pretend that this is your final report that you're writing up here. And just to show you a couple things that I've done here. First of all, at the top here, I put down the question numbers from the survey. Of course, this is a made-up question, but let's say they were questions 29 and question 6 from the survey. And so we see what those questions are. They're about community and they're about experience delays due to highway construction. And that's very useful for when you're reading. And then I've got a footnote here. And the footnote here then says right down at the bottom, see page 24. So of course I just made up that number, but 24 would be the page in the main data analysis where you're talking about your results. So this page here is in your appendix, but page 24 is where you actually are talking about this relationship here. And on page 24, you want to have a similar footnote where you talk about the relationship, and then you would say, see page, let's say this is page 82, so see page 82. So they're cross-referenced both ways. Now, here's the results that I've got, and I've mostly just cut and paste these from the template. The problem was that it was very wide, and so that would spill over the page here. It doesn't fit on a portrait size page here. So I just cut and pasted the parts that I needed here. So the test of independence. Originally, this simply said that the two variables are independent, and so I changed them to community and opinion on highway delays are independent versus the alternative that they are dependent. And then what I've done is I've put down the little box here for the results, and that shows that there's a strong relationship here. I put down the observed frequencies, the expected frequencies, and the adjusted standardized residuals. You'll also notice that I got rid of all the excess columns and rows that were on that original template here, so it's much tighter now. I changed the name here. So originally I had G/W/W, and I put down that those are just small, and then the note down here, small communities include Gwyn, Westerose, and Winfield. And then you describe the relationship. So down here, you start here with the marginals. And so this one here then is saying of 337 respondents who answered both of these questions, 45% came from Edmonton. So you'd get out your calculator and figure out that 166 here came from Edmonton and 49% from Calgary. I think I actually had those backwards there. The smaller number is actually from Calgary, isn't it? So let me just change that. Calgary has the smaller number, and then Edmonton had the larger number here, like that. And 6% from the smaller communities, and so on. Then 45% answered yes, 42% answered no, and 12% answered no opinion. By the way, the very first statement there about 45% from Calgary, 49% from Edmonton, and 6% from the smaller communities, you may not have to include that because that might be described in your demographics section right at the beginning of your data analysis in your report, so much earlier up. And then I describe the relationship here. And so this is talking about here then these standardized residuals, adjusted standardized residuals here, and which ones are significantly higher and which ones are lower. And so that is it. That's how you write up the question in your report. And I think that's where I'm going to end the video here. Thanks for listening.